We're going to continue on with our example looking at a confidence interval of the difference between, or the list of differences with matched pairs. Now, because we got down to a single column of data that we care about, all of which are numbers, we're actually going to be looking at the top row here for doing our analysis. This is a little bit different since when we started out the quarter we were looking at these options down here, anything that dealt with one quantitative, one categorical, two categorical, or two quantitative, because we always had two variables. Here we still have two variables, but because we boiled it down to a single difference, a single list of numbers, the way that we analyze this matched pairs data is a little bit different. We're going to be looking and treating it like it's a single quantitative variable. So all these calculations you have already done in the past in this class. However, how we interpret it is going to look a little bit different. So same calculations, a little bit different interpretations. So we're going to start out with that confidence interval for a single mean. We open that up, and when we look at our data, we will go to Edit Data, and we will replace this with a list of the differences. So our list of differences might be 5 for the treatment A was 5 more than treatment B, followed by 1, A was 1 more than B, followed by -4 because A was -4 better than B, which really means that B was 4 better than A, or higher, not necessarily better, but higher. And you could continue to have this list of differences that your study found, and so we're going to enter in this test data for this situation. And after you have that all entered, you will run the many resamples just as we've always done. And what you're calculating is a confidence interval for how much the difference is, how much the average of the differences is. So we're going to calculate the average of the differences, and we do that with a two-tail test, or a two-tail display here. Since it is a confidence interval, we want to know what the middle 90% or the middle 95% is. And so in this case, it looks like our 95% confidence interval of the difference is between 0.125 and 6.188. So now let's go ahead and interpret that. It's going to follow the same form that we're used to say that I am 95% confident, because 95 was the number that we set as the percentage of outcomes we wanted to capture. So I'm 95% confident that what? That the average difference is what we're going to focus on. The average difference of, so we're saying average difference because it is the average of a list of differences. So the average difference of medicine A minus medicine B is between, and then we're going to use the numbers that we got from Statkey earlier, which is going to be 0.125 and 6.188. Blood cells, because we were counting up blood cells. And so again, if we take a step back and look at this, 95% is how confident we are that this answer that we gave down here is going to be accurate, that it's going to be truly the difference between them. We don't say the difference between the average of medicine A and then average of medicine B, because we don't average these separately. Instead, we subtract each one initially for each person or for each pair of twins, and then find the average of the list of differences. So that's a little bit different than two sample, which we'll see later. But I'm 95% confident that the average difference of medicine A minus medicine B is between 0.125 and 6.188 blood cells, or whatever it is that we're studying in this case. What we do with a statement like this, we will look at more as we get into applied projects and look at some of the example problems. But you'll notice that the entire 95% confidence interval is above zero, meaning that medicine A, we predict that medicine A is always going to have result in more blood cells than medicine B, or at least within the 95% interval. So it seems like there is a pretty statistically significant difference between the two medications in this study. And when we get to the hypothesis test, we will confirm that by using a p-value, one-sided or the other.